So in this session, we'll discuss some application development on IoT and some latest technological view for machine learning and artificial intelligence. So is it visible? The site, the presentation is visible for all?
No.
Presentation is not visible?
No, sir. Not. It's only your screen.
हाँ सर उसको स्क्रीन कर दिए, शेयर कर दिए. हाँ yes sir, visible.
It's visible. Okay.
Now this is visible.
So because of some slight difference in this presentation schedule, Dr. Vishwakarma from IIT Indore is not available because of some issues with technical issues with his mobile or internet facilities available at his home. So I'll take this session, and this session is just an interactive session with this participants and the coordinator. So what basically you more required from this FDP, if you feel some gap or some more related information in kind of some other subjects or other areas, so you can let me know so that we can arrange more experts in that area. So if anybody feels that this area is lagging or this area is not covered in this part, so that we can cover during the next remaining 5 sessions. So I'll call that expert accordingly and I manage that sessions. But if you are fine with that, then I'll start my presentation on this IoT, what we are doing at IET, what are the perspectives of Google Coral systems. Actually, we are working on this TPU systems. So we are the part of that project, TPU project. So I'll explain what we are doing with this TPUs. So if anybody, any participants have any query or any related suggestion, they can write. Or they can unmute their mic and they can share their experience with that. So I think I start with that, whatever I have. So this presentation talk is a complete review of this, what we have learned from this total 8 sessions. So we have started with the first session, and from the Dandekar sir, we learn about that Wi-Fi module and ESP232. Then from Anirban session, we learned about that security perspective of these IoT systems. What are the major perspective we must consider when we design some IoT systems? So that the security, hardware security, some watermarking, some fingerprinting, how to avoid the Trojan in hardwares, and in case of IoT systems, because the data is traveling from home devices or the sensors to this gateways or gateways to the cloud. So in between, there may be possibility that your data is stolen, or there may be some mishappening is maybe possible with this your data. So to do that, we must have the option. We must consider the security perspective of IoT systems. So Dr. Anirban's cover almost all these aspects of this IoT system security model. So he covers so many things about the watermarking and other parameters we must consider during the IoT system designing. Then we had very good lectures from Dr. Rajkamal sir. He explained what is the future perspective of this, and what are the microcontroller or microprocessor is available, and how practically we can use these IoT models to get the benefited from in all over the sectors. Then we have a lab session with Abajan madam. So she explained that how to initially how you will start your designing of first IoT systems, what is the Raspberry Pi and Arduino systems and all this, the specification of that. Then today we have a very good interactive session from the Puneet Gupta sir from IIT Indore. He delivered a very nice talk on that phase recognitions, how to recognize a phase, what is the scooping of the phase, and what different parameters we must consider when we apply some algorithms, IoT algorithms for the face recognitions. So we had 2 sessions, the 2 morning session with the Puneet sir, and now the last third session I'll cover. And basically, I cover what I feel that they must be there in their presentation. So the first thing is the simplest way of the Internet of Things. So the Internet is word is the Internet means this word is not new. This word Internet is mining from the 1930s. So the Internet appears whenever everywhere in the world, but it is still connection between the peoples to people. So in case of Internet, the peoples to peoples connections, we connect the peoples through the mobile phone, through the computers. So connected peoples are net called as a net. But due to the advancement and due to the other technologies improvement, the next era of this Internet of Things is coming into the picture is in around 2010, 2012. And that is apart from this connection of peoples, we have the connection of objects also. So we connect so many objects through the Internet. So that is known as the Internet of Things. The question is that why do we want to connect this object to the Internet? So we want to connect the objects to the Internet so that we'll get the information from the object, we process that information, and we do some needful for that application development or some data collections part. So that is the Internet of Things. We have learned so much about this Internet of Things during the first eight sessions. Now, what the Internet of Things? What basically Internet of Things is that before to the Internet of Things, we have the two dimensions of connectivity. The one is any place connection, and second is the anytime connection. So any place connection means at the PC to PC connection, indoor, away from the PC to connection, outdoor or on move connections. Anytime connection means at day, at night, at outdoor, at indoor, at on move. So before to this IoT era, these two dimensions are already exist, and so many products and the applications are available around these two dimensions. But as the Internet of Things comes into this era, it added the new dimensions in the designing and the perspectives of this new technology that is known as anythings. So now we have the three dimension: anything, anytime, anyplace. So this anything is because in between the computers, PC to PC, or in between human to human interactions, not a PC, human to thing interactions using the generic equipment, or thing to thing interactions. So because of this new era, that is the new era, the third dimension is added to this technology perspective that is known as anything. So now we have the three dimension: complete direction, any place, anytime, anything. So that collection of the three dimensions is virtually known as a Internet of Things. So as I hope we have already discussed this Internet of Things, the definition in the first lectures. The definition is the Internet of Things, also called the Internet of Objects, refer to a wireless network between the objects. Usually the network will be wireless and self-configured, such as a household application. This is the Wikipedia definition for Internet of Things. So according to the definition, the Internet of Things, also called as the Internet of Objects, the interconnection of objects, refer to a wireless networks. It may be wired. It is not compulsory that it should be wireless network. It should be wireless or wired network between the objects. Usually the network will be wireless and self-configured, such as a household application. So this is a Wikipedia very common definition for Internet of Things. And the definition of is WSSI 2005 is presented by the first time that is the definition is by embedding the short range of mobile transceiver into the wide array of additional gadgets and everyday items, enabling the new forms of communication between the peoples and things that between the things themselves. So this is the first definition that was coined in WSSI 2005, the world famous conference in communication. So by embedding a short range mobile transceiver into the wide area of additional gadgets means your gadget is as we already discussed that we have the objects since from the 90s, 70s, 80s. We have objects like the refrigerator. We have the TVs. We have the mobile phones. We have the microwave. So the objects are there, but the objects are not able to communicate with each other. But they do not have any mode of communication in between or communication interaction with the human being. So by embedding the short range means if we put a short range mobile transceiver, they transfer and receive the signal into a wide area of additional gadgets and everyday items. then enabling the new form of communication between the people and things, and between the things to things themselves. So this was the first definition that was coined in WSS 2005. So these are the simple definition of this IoT. What is IoT, and why the IoT is because the third dimensions of the IoT is introduced in this technology era. And these are the simplest definitions from the Wikipedia and WSSI 2005. So we further proceed to our this lecture on this. So what application area we are looking for, and what are the benefits of this IoT? So we are looking some examples of these IoT systems. Before to that, I'll go to that. Is there any? So is there any doubt, or is there any clarification required for this? I think no. So if suppose we have the Internet of Things, then how the world is changing because of this Internet of Things. The Internet of Things is now.
Sir, excuse
Yes,
me.
Yes,
Can
yes,
you display it for full screen actually?
Full screen. Okay, ma'am. Okay.
Yes, sir. Yes.
Actually, I have to switch from this PowerPoint to the Google Meet.
Okay.
Otherwise, मीन्स ये पता नहीं लगता है कि आप आउट भी हो गए हैं और आपका कनेक्शन लॉस हो गया, क्योंकि मैडम अपने आईटी में कुछ कनेक्शन का इशू हो रहा है यहाँ पे। तो इसलिए मैं ऑन करेंगे। चलो ठीक है, फिर मैं आपको फुल, पर आप अगर मैं आउट हो जाऊँ तो मुझे बता दीजिएगा कि आपका प्रेजेंटेशन बंद हो गया है। अदरवाइज वो चलता रहेगा, मुझे पता नहीं लगेगा।
नीमा सर, यदि आपका
Yes.
वीडियो ऑफ कर देंगे तो साउंड क्लियर आ जाएगी, बैंडविड्थ बढ़
वीडियो
जाएगी थोड़ा।
विच वीडियो?
आपका
मेरा वीडियो ऑफ कर दूं। ठीक है,
साउंड बैंडविड्थ अच्छी मिल जाएगी।
ओके ओके ओके, आई विल। ठीक है सर, ठीक है। So we continue with that. So now what the applications of the internet? So as we know that the IoT, the Internet of Things, is all over, means in all the fields of engineering, and everywhere is the IoT is there. So हर आदमी बात कर रहा है कि IoT systems की। तो IoT system कैसे impact कर रहा है in the day-to-day life में? तो this is a simple scenario for healthcare system. So because of this COVID, after this COVID effects, the National Health Information Network electronic patient recording system develop किया है गवर्नमेंट ने। In this systems जो old age peoples हैं उनको इसमें इन्होंने register किया है, and they provide basically a model दिल्ली में adopt किया है दिल्ली गवर्नमेंट ने। They provide the pulse oximeter, blood glucose monitoring, influence pump, and accelerometers to the patients. So from the home, from the house, we continuously monitoring the health condition of this patient or the old age persons. If suppose we found any means, because we know that because of this COVID and because of pandemic situations, the situation at the hospital is very difficult, very tough. Means no beds are available for the patients, and if the patient having the mild symptoms of this COVID, so government preferably wants that the person should be home isolated. And apart from this home isolation, we have to continuously monitor the health status also. अगर health status degrade होता है तो we immediately get that patient to the hospital. So how it will be possible? ये कैसे करें हम? तो एक Internet of Things ने बहुत अच्छा solution provide किया, और जिसको बहुत सारी government अभी adopt कर रही है। In this system, they provide a basic monitoring facilities to the person, to the patient, and it continuously monitoring the health status of the patient. And after the monitoring of the health status of the patient, it transferring to the base station. The base station means station where this data is collected, and that the data is again transferred to the cloud or the processing unit. That processing unit process the data, and if it found that some parameters, it may be some patient, if the parameter is matching, if the parameter is not matched with the ideal parameters, then it consult with the doctors, and the doctor feels that the patient has some emergency condition. They send the ambulance to the home of the patient, and the ambulance pick the patient to the hospitals. So this is a one type of model. And if the doctor found that the situation is not so critical, so he provides the medicine to the patient through the online this transfer mode of the medicines. So this model is very famous model, and this model is very appreciated by the World Health Organization also. So this model is basically an example of IoT systems in healthcare system, healthcare objects. The second is a second example, as the Puneet in the morning session, the Puneet told that the healthcare system. So a new product is come up with this healthcare system. That product is for measuring the blood pressure, continuously monitoring the blood pressure of the patients. So nowadays we have the traditional machine to measure the blood pressure, but it is very difficult to continuously monitor the glucose level or the blood pressure of the patient. So they implant one unit inside the patient brain. That is this kind of this is a dissolvable circuit. The dissolvable circuit board is there. So various sensors from the various condition. Example, the ICP sensors, short or the long terms monitoring of the pressure and the brain activity, implanted in the brain cavity and sense the increasing of the pressures. The sensor and associated electronics encapsulated in the safe and biodegradable materials. External RF readers power the unit and receive the signal. Stability over the 30 days so far. So this is a kind of product which is developing in a healthcare system because of this pandemic situation, and this is in trial mode, and this is developed by some Israel health product development company, and is in trial mode now. So now, apart from this healthcare system, the home automation is also one of the famous area for the IoT applications. So we have in our home smart, that is known as a smart homes. We have the different types of sensors now. We have fire alarm sensors, we have the IR cameras, we have the sockets, light sensors, air conditioner, washing machine, and all these gadgets. Whatever the gadgets you consider that gadgets, all are connected in internet-enabled gadgets. So with the help of these internet-enabled gadgets, you can monitor the present status of all these gadgets, and according to the monitor of the gadgets, you can take some actions. For example, suppose your air condition is a Wi-Fi enabled air condition. So this air condition continuously monitoring the home temperature, your temperature of your house, and if you require to control that temperature of your house from the office, so with the help of this IoT enabled process, you can control the temperature of your house through that app or through the mobile phone. So that is again application area of this IoT in a home automation or a smart home kind of things. Then we have application area in the shopping scenario also. So shopping, in case of shopping scenario, if suppose you enter in, you have a list, you have a digital list of your shopping list, and as you enter into the mall, the shopping list guide you that key where the product is available. So you pick that products, you see what category of product is there, and what the specification that product have. That product introduce itself to the consumer, and if the consumer feel that this product is matched with the specification what it required, the consumer pick that product. As it pick the product, the position of that product is sent to the storekeeper that product is the product is now not there, so you can put the new product here. And apart from this, as this product is put into this basket, automatically billing and the information is sent to that customer this billing section, and automatically the amount is deducted from your credit card or whatever the payment mode is there. So that is a shopping scenario in IoT systems. So the IoT is in healthcare, IoT is in shopping, IoT is in smart home systems. Apart from this, IoTs exist in this automobiles also, because we know that most of the companies are now working on this driverless car system. The Google is working on the driverless car systems. The Elon Musk is working on this with the Ford. All these automobile companies are now moving towards this driverless car system. So driverless car system means what? The car is having around the 200 number of sensors, which sense all the condition of the car, and we real-time process that data, and according to the data, we take the decision. So automatic car and the driverless car is again one of the example of these IoT systems. So the thing is that here the IoT system means the level of application. According to the level of application, the processing and the capturing of the data is entirely different. Means a single IoT solution is not applicable to all applications. Means suppose you have a particular Raspberry Pi board, or you use particular Arduino board. So that Arduino board or that Raspberry Pi, single Arduino board or Raspberry Pi is not useful for all kind of applications. So we have, according to the application, according to the requirement, we have to change our hardwares. So how to change our hardware, we will discuss in the later part of this presentation. So this is I have taken from some website that life in the IoT era. The IoT International Technology User Roadmap has described the sense of the IoT era as follows. The car will generate alarm automatically if the driver has made any mistakes during the operations. So that is a one scenario. The bag will send the out reminders message if the owner forget to bring something. The cloth will tell the washing machine about its requirement for the water temperature. So that is a era of IoT. The life will be changed completely with the technology of IoT. So IoT is a upcoming area. Apart from this IoT, the AI machine learning are the again common areas. They completely change the lifestyle and all things of this human being. So now the IoT is the IoT get the popularity after this situation. As you heard about after the Fukushima disaster on that Japan, the radio reactor is there. The reactors, in that reactor, this some gases and some nuclear fuel is get disordered or destroyed, and because of that the level of radiation is very high. So how to measure? Because it is not possible to measure the this radiation level by the human being. So they deploy so many number of sensors with the patch hub facility. What is the patch hub? We will discuss that in the later part of the presentation. So they deploy so many number of sensors, and the sensor sensing the radiation level at that particular area, and according to this particular measure the radiation level, they perform some actions. So the IoT system and this IoT sensor node are get very popular after this disaster, the Fukushima disasters. So you can see that initially the sensors is deployed and the radiation level is very less, but after this pandemic situation, that in 31st March 2011, the radiation level is very high, and the radiation level is monitoring by the sensors, continuously monitoring by the sensors. What the radiation level is that. So it's one of the very good example for IoT systems which save the life of the human beings at the place where the human interaction is not possible to get the data or to interact with this machine. So this type of applications are very useful using the IoTs. So the question is how to design the IoT systems. So if anyone have any query, so let's see. So any doubt regarding to this lecture or any? Okay, so I'll continue that. So how to design this IoT systems? So as we know that the designing of IoT systems is based on this 4-layer model, where the lowest layer of the model is sensing and identification. Then the second layer of model is network construction, and the third layer of model is information processing, and the fourth layer of model is integrated applications. So in case of the first layer, the lowest layer of this IoT 4-level model is the sensors. So to identify, to get the informations, to calculate the various parameters, and to sense the various parameters, the physical thing is that the sensors. So at this layer, we deploy so many types of sensors, and apart from this, as we have already discussed, that the sensors with the processing unit is also available now, and sensor with this the communication ports, suppose BLEs and Wi-Fi modules is also available to transfer the information to the base station or the gateway or to the cloud. So the first layer in this IoT system is IoT development system is the sensors. So GPS sensor is there, smart devices are there, RFID is there, sensors, the sensor node is there, and many other kind of sensors are available. Then after the sensors, once we sense the data, once we have the data, we send this data to the network construction layer. The network construction layer means the various type of network it can have. It can have the WWWAN, it can have the WLAN, it can have the internet, WPAN or WMAN. So according to your application, you select the type of network, and according to that network, you route your data towards the cloud. Then at the information processing center, we have the data centers, the data centers, search engine, smart decision, info security, and data mining. So at the information processing center, we have a high processing unit, high processing CPUs that process the sensed data, and according to the sensed data, they perform some applications. So integrated applications such as smart logistic, smart grid, green building, smart transportation, and environment monitorings are there. So these are the few examples to application where this model is applicable. So this is a simple 4-layer model of this IoT system. So to design the IoT system, what we required first sensors, then we require a network to which we communicate our data, and we required a processing unit that is known as information processing, and then we require the particular integrated application. So this is a very general 4-layer model for this IoT systems. Then the thing is that how this Internet of Things means, how the Internet of Things changed the scenario of this hardware perspective also. Because earlier, before to the Internet of Things, all this manufacturing, the semiconductor manufacturing companies is mainly concentrating to get the highest speed of processor. Means they have the 12 core, quantum core, tetra core, and number of cores. Means they continuously improving the number of cores so that the processing speed of the circuit or the CPU is continuously increasing. But it is not. In some cases, it is not required that we should use a high processing systems. Okay, in all the cases, in all the applications or in all the cases, it is not required. It is not required that we should use a high processing unit. Many applications require the true processing or either required to collect the information from the sensors. So a processing unit only required to get the data from the sensors, process a very small processing over the data, and transmit the data to the some node or transmit the data to the cloud. So in that case, to process the data, a very few amount of data is available. So to process this data, a very high performance system is not required, because the high performance systems are mainly required a higher power. So at the low power solution, what we have to do, so in some cases, in some application, the IoT application, we require the sensor and a small processing unit. And our major constraint here is that the sensor and this processing unit should work on the lowest power. Lowest power means they should work on the battery operated. They should work on the battery powers. So our major constraint is that the attached of the various sensors with the CPU is difficult, and not just in terms of use and requirement performance. It is obvious that the CPU, the high processing CPU is not required to get the data from the sensors. A simple processor, this Arduino board simple 8 Mega 328 is sufficient to process the data provided by the sensors. As continuously increasing in the performance required lots of data to be analysis, and for the collection of the data we need a hardware. So obviously to collect the data we need a specific hardware so that we get the exact information from the environment. Suppose we have to calculate the pressure, we have to calculate the temperature of a specific area or a specific room, and we can what we are. Yeah, so we are here that the main objective of this that in case of Internet of Things, it is not required that we have to process a large amount of data. In some cases it is required, but in the most of the cases where we measure the temperature, where we measure the pressure, where we measure the humidity and all this, the high processing unit is not required. So what are the basics of this Internet of Things? The main basics of the Internet of Things, because of the Arduino board, it's open source, means open to access the all. In 2005, the Massimo Benzi and the David Cartelers created Arduino as an easy to use programmable device for interactive art design project at the Interaction Design Institute, Italy. We need to digitize what is the objective, what objective they have in mind. The objective they have in mind that we need digitalize the things to get the digital data for the computers, because we have the large amount, we have the high processing unit of the computer, but if the data is not there, then किसको process करेंगे? So we required a large amount of digital data. तो ये digital data कहाँ से मिलेगा हमको? तो digital data gather करने के लिए they introduce the Arduino board. So we need to digitalize the things to get the digital data for the computers. We need to measure the physical things like the distance, light intensity, speed, etc. and digitalize the measured result for further processing. Need an open source hardware that is capable of measuring the data and digitalization of the data. Most popular hardware to collect the data in Arduino, and Arduino is an open source hardware. Anyone can modify or program it as required. So these are the main objective of this Arduino board. The main objective of this Arduino board is to create the digital data, because objects are there, but the objects we have, if we have the processor with the lots of processors, we have the 12 cores, 16 cores processor, but the data is not available, then how will you process? What will you process? So to process the data should be there. Or data kahan se milega? Data humko milega when we sense the data and convert that data into the digital format. The Arduino is the best example to connect the sensors, to get the data, digitalize the data, and provide the data for the further action. So that is Arduino. Then after the Arduino, the introduction to Arduino, the Arduino has a microcontroller inside. It can be programmed to do many different things. You can read the information from the sensor for the instance. For example, read how the bright it is in a room. You can use this photoresist, which is sensitive to light. You could detect when someone walks into the rooms. Sample of the different kind of inputs that the sensors provide. But what can you do with the data using the output? You can control the device or display and store the data. So this is Arduino has a controller, and you can connect any sensor with the controller. You can connect the temperature sensors, IR sensor, motion sensors, and it sends the data, and it sends that object and convert that into the form of digital, so that you can process the data. So the main objective, the main purpose of this Arduino board is to get the information and convert that information in digital format for the further processing. This is a pinned out diagram of this Arduino board. So in Arduino board, generally we have 8 mega 328 processor, 8 mega 328 microcontroller IC. Then we have the VCC, MOSI pin and ground pin, and MISO pin, system clock and reset. And generally we divide into the analog input and digital input to this Arduino board. So we have around the 6 analog input ports, and we have around 12 digital ports. So in some cases we have this hash mark work that represent that the digital output is in PWM form also. So we can use analog sensors to get the data, and we can have a digital input and output pin also to get the digital input or to provide the output to the to perform some actions. So that is the main beauty of this Arduino board. Analog and digital input both are available. This Arduino board is operated on this 16 megahertz of crystal frequency. It has a USB-B port, computer reset button, and it has some power supplies of 3.8 works on 3.3 supply voltage, and RXT and TXT pins are used for the communication. Two interrupt pins are also available. The pin number 283 as interrupt pin, and the MISO for the serial communication. We have the SCK, serial clock, master in, slave out, master out, slave in, and slave select signals are also there. And inbuilt LEDs there. The LED connected it to the pin number 13. So that is a simple architecture of this pin out diagram for this Arduino board. And to perform some actions using this Arduino, no interpreter is required, no operating system is required, or no firmware is required. You just have an ID, a software. You just download that is freely available. You just download that software, write a simple program, and burn that program into the Arduino. So the Arduino perform that action. So it's very simple to use. No interpreter, no operating system, no firmware is required. to program this Arduino boards. Then the advanced version of this Arduino is Raspberry Pi. The Raspberry Pi is Evan is a creator of the Raspberry Pi and co-founder of the Raspberry Pi Foundations. This is a Raspberry Pi, one of the cheapest and the smallest computer. Few years back, the Broadcoms, a company that manufacturing the smartphone chipset, joined hand with the University of California, and after a few years, this Raspberry Pi was born. Though initially it was designed for the kids to learn the programming and for the third world country can have access to cheap yet functional computer. Later, when the Greeks found about the Raspberry Pi, they start doing all sort of cool projects. So initially, the Raspberry Pi was developed for the third world country to learn the computer programming. So it's a smallest and cheapest computer. That was the initially the intention is to train the kids for the programming. But later, if they found it is very useful, so they created so many cool projects with the help of this. The first Raspberry Pi version Model A was introduced in 2012, but over the year there have several versions related to this. The small Magic box supported the Linux, and the most popular one is the Raspberry Pi. The Raspberry Pi is itself operating system for this. This is a Raspberry Pi Model B space. It has a CPU of ARM 1174 JZF. It's work on the 700 megahertz of frequency. GPU is a Video Core 4. The RAM is a 256 megabytes of RAM. It has a port, USB ports, HDMI port, RCA ports, video out के लिए. We have the stereo audio in out, Ethernet 10 to 100, GPIO header, micro USB and SDHC slots. So this is a simple Raspberry Pi model, and the latest Raspberry Pi model has a Bluetooth and Wi-Fi module for the remote connection, and also have the fast Ethernet 12.2.4 gigahertz and 5 gigahertz of wireless LAN also. So this is a more advanced version of that, we can say, Arduino board. So it has Raspberry operating system, or you can use a Linux. Now, if you compare the many people get confused when they compare the Raspberry Pi and Arduino boards. So if you compare the Raspberry Pi and Arduino boards, so according to the specification, the Arduino Uno single board microcontroller, it's a microcontroller, and the Raspberry Pi is a microprocessor generally. So in case of Arduino Uno single board microcontroller, control unit 8 mega 328 microcontroller, RAM is 2 kilobytes of RAM. The CPU architecture is 8-bit of CPU. Operating system is no. The processing speed is 16 megahertz. The power consumed is 775 milliwatts, and I/O current driving strength is 40 milliamperes. So these are the specifications of this Arduino Uno boards. And for Raspberry Pi 3B Plus, the single board computer, the control unit Broadcom DCM 2837BO SoC system on chip. The RAM is 1 GB of RAM. CPU architecture is a 64-bit architecture. Operating system is yes. The processing speed is 1.4 gigahertz. The processing speed, if you compare the processing speed of this Raspberry Pi is very high compared to this Arduino board. It's 16 megahertz only, and here we have the 1.6 gigahertz. The power consumption, in case of power consumption, the Arduino board is power consumption is very low. It's 175 millivolts, but in case of Raspberry Pi, the power consumption is 700 millivolts. The I/O current driving strength is 16 milliamperes. Here is the I/O current driving strength is less, and here we have the I/O current driving strength is around 40 milliamperes. So high driving capability is here in case of Arduino, and low driving capability in case of Raspberry Pi. The modes of operation does not support the Arduino and GUIs. Arduino specific IDE and compiler. Use the shield for extended functionality. Suppose you have to use a Bluetooth, or you have to use a Wi-Fi module, so you can use a shield. The shields are available. You use that shield and you make this Arduino board enable as a Wi-Fi modules. Best as controlling machines and performing a repetitive task. It is mainly used to controlling the machines and performing the repetitive tasks. If you compare with the Raspberry Pi, then it supports the audio and GUI both. It supports the audio GUI both. The wide range of operating software is available. Use the heads for the extending the functionalities. Best at the logic processing of the data and communication with the other systems. So this is a comparison between Raspberry Pi and this. So if you look at the general, in a layman language, definition, The microcontroller is a powerful. It's a more powerful because it has a driving capability of 40 milliamperes. It is used to perform the tasks which are repetitive tasks. It is mainly used to sense the data, and it is not used to do some processing power. The processing means the Raspberry Pi has a brain, it has a CPU, but the microcontroller, it has a muscles, is a power. So if you want to connect, if you want to sense some parameters from the some remote location, the microcontroller is best. But if you want to process some data very fastly, very effectively, the Raspberry Pi is better. So you have to select according to your application which one is better for my project, which one is best for my projects. So Arduino board is certainly for the sensing of the data and presenting the data, but Raspberry Pi is generally for the processing of the data. The GPU, CPU type of processing if required, image processing required, video processing required. So we generally use Raspberry Pi because video processing and image processing and GUI kind of things are not possible with the Arduino, because the Arduino has a very limited processing power and the Raspberry Pi has a very high processing power limit. So this is a comparison between Arduino and this. So, but in case of smart devices, so apart from this Arduino, means the smart devices in IoT represent the biggest growth potential. Once again, I will plug in.
वैभव सर आपका माइक है ना म्यूट हो गया क्या?
Oh, sorry. Now it is fine. आवाज आ रही है आपको?
अरे ठीक है सर.
Okay.
Yes.
Okay. So apart from this IoT, the new term that is mainly catching to the people's are artificial intelligence, machine learning, and deep learning. So actually the artificial intelligence and the machine learning is some sort of extension version of IoT systems. Because in case of IoT, if you understand what is IoT means, in case of IoT systems, from the sensors we are sensing the data, we process the data, we send the data to the gateway, and from the gateway we send the data to the cloud. Cloud perform some functions, do some function, and then according to the function it takes the decision. So that is a different layer are there in case of IoT systems. So first we're sensing the data, the layer 1 is sensing the data, layer 2 is processing the data, layer 3 is a gateway, layer 4 is cloud, and layer 5 is application. So the 5-layer structure is there. So in case of artificial intelligence means what? The machine itself sends the information, machine itself process that information, and according to that it will get the results. So in this case, there is no transmission, no communication of the data from the gateway to the edge devices or to the CPUs or to the GPUs. So in this case, if the communication channel is not there, then the response time of the system will increase. And but for that, for artificial intelligence or for machine learning type of applications, we require a very high processing unit. We require the processor. Our processor should be a very high power. High power means it can take the decision, it can process the large amount of data, and it will give you the real-time information also. So that is a main difference between the artificial. If suppose we have to compare the artificial intelligence and Internet of Things, the Internet of Things means what? We have processed the data at the cloud and we get the information from the cloud. So there is a communication between the sensor and the cloud. But in case of artificial intelligence, machine learning kind of application, we do not require to send the data to the cloud. The machine itself learn. Machine itself is a powerful to learn from the data. It has some algorithms. We train using some algorithms, and according to the algorithms, according to the previous model, it take the decision. What we have to do for this type of input. So that is known as a machine learning. So we'll try to understand more detail in this case. So suppose it's artificial intelligence. Artificial intelligence means what? It is a technique that enables a machine to mimic the human behavior. Suppose machine is here and the human is here. So we try to get that the machine should behave like the human being. That is known as artificial intelligence. Now, artificial intelligence कैसे बनेगा? So that is of machine learning is a technique to achieve the AI through the algorithms trained with the data. So what the machine learning is? Machine learning is that we have the data set and we have the inputs. So with the help of data set, we try to make the machine learn. Means we develop some algorithms that the machine get learn from that previously provided data sets. And if a new input is coming, new input is coming to the machine, then machine from the past experience recognize that inputs, and according to that it takes the decision. So that is known as a machine learning. The deep learning is an inside part of the machine learning. The deep learning is a type of machine learning inspired by the structure of human brain. In terms of deep learning, this structure is known as artificial neural networks. So in case of machine learning, the algorithms are developed, or the structure of these algorithms are in the case of the human network, neural networks, the artificial neural networks. The neurons are there; they are interconnected. They are interconnected to each other. The neurons have some activation function. Neurons have some potential. So all these features we try to put in a circuit, in a hardware, so that it will behave like a human brain. So that is known as a deep neural networks. So the three main point terms are here. The first one is artificial intelligence, second is the machine learning, and third is a deep learning. So how this model are different from the IoT? This kind of model, the artificial intelligence kind of application, how will develop? So let's begin with that. So first we understand what is a machine learning. So machine learning is what? The machine learning means we have the trained data, we have the data sets, and the machine learning algorithm. So from this data set, we draw some sort of algorithms, and from the algorithm we develop some model. So this model we apply here. Now, if the new input is arrived, from this model, it predicts that what should be the output. This is the output. If the prediction is right, the prediction is correct, means that model which we have designed is a successful model. If the prediction is wrong, means we have to further train our data. So this is a simple example of machine learning. So in case of machine learning, so what we required in case of machine learning, the thing we required, the model is the accuracy of the model will depends on to the data sets available to generate algorithm for that models. So the data, where we generate the data, from where we get the data, we get this data from the IoT enabled nodes. So we get the data from the sensors, the actual data from the sensors. So जितना बड़ा डेटा, huge amount of data is available, the model उतना accurate बनेगा, but उतना ही हमको processing power भी लगाना पड़ेगा. So that is machine learning. कितना close machine learning model, कितना 100% machine learning model follow हो रहा है, successfully use हो रहा है, वो depend करता है कि what data sets you have accessibility of the data sets. If you have the huge amount of data, the various kinds of data is available, then the model is perfect model. Both कम data sets से बनाएंगे तो model may be the probability of model is the probability of to identify the things is maybe wrong. So it will depends the कि prediction कितना सही है वो depend करता है कि आपका data set कितना strong है और कितना data set पे model कितना अच्छा बना हुआ है. तो that is of machine learning. अब machine learning generally दो type की होती है. One is a supervised learning and second is known as a non-supervised learning. A supervised learning मतलब ये होता है कि a closed loop path is there. A closed loop path means we have the trained data set, है ना? And the supervisor is there. Supervisor को पता होता है कि suppose it's a raw inputs from the trained data set. If I show the picture of this apple, the trained data set बोलेगा कि this is apple. अगर desired output है तो supervisor बोलेगा ठीक है. अगर output गलत दिया तो supervisor उसको train करेगा, वापस से train करेगा. तो supervisor under the supervision of some parameters, we do the machine learning. So suppose we have the raw data of this apple, we develop some algorithms from under the supervision of someone, and from that we process that data and train the model. हमने model train कर दिया. Now we show this green apple instead of red apple. We show the green apple. So because the model is trained and it easily identifies it's an apple. So that is a type of machine learning. That is known as a supervised machine learning. And the unsupervised machine learning means the no supervised there. The machine itself get matured after the amount of time. Means it continuously monitors the data, continuously do the processing. So that is unsupervised learning. Suppose we have the raw data and we have to classify this. हमें इनको fruits को classify करना है कि apple को अलग करना है, banana को अलग करना है, mangoes को अलग करना है. तो unknown outputs हैं, no training data sets available, good data interpretations हैं, and algorithm develop किया, processing किया, and we segregate this. This is output. This is a trained model. So unsupervised and supervised learning होता है in case of machine learning. And the deep learning means working of neurons. Suppose you say, suppose in a class you say that you write a 9. So it may be possible कि ये ऐसे no लिखेगा, it may be possible कि ये ऐसे no लिखेगा, it may be possible कि ये ऐसे no लिखेगा. But we can easily recognize. But to machine to recognize this as a 9 is very difficult. So how to train a machine to recognize this type of means how we have to train the machine so that it can easily recognize this type of problems. So how to train the machine? So that is known as the deep learning algorithms. So in case of deep learning algorithms, whatever the image is there, we convert that image in form of pixels. Suppose a 9 is written, the 9 we convert into the 28 by 28 means 784 pixel values of pixels. We provide in case of deep learning on in case of deep learning model, we have the input layer and we have the output layer. In between the input and output layer, we have the hidden layers. So अब इस case में बहुत सारे पूछते हैं कि how many number of hidden layers you have used for your model development. So in this case, we have used 2 hidden layers. You can increase the number of hidden layers, but as you increase the number of hidden layers, the complexity will increases, and you require to do the more and more processing. If the hidden layers are less, if you use less number of hidden layers, then your output function is not so accurate. So we have to compromise. There is a trade-off between a number of layers and the CPU speed. So we have to maintain that trade-off. कि मुझे कितना accurate model चाहिए, मुझे कितना accurate कितनी जल्दी output चाहिए, कितना कम processing rate में output चाहिए. So that is known as a deep learning. तो हम learn कराने हैं system को. So we provide here we have the inputs of x1 to x78. We provide pixel value to each input, and according to the pixel value, the hidden layer is there. Hidden layer identify the weightage of these pixel values. हर pixel का कितना weightage है. According to the weightage, according to the circle, according to the images, according to these values, it identified and give you the output. The activation function is there. The activation function gives the output that this is written as a 9. So this is known as a deep learning algorithms. Now we develop a model for this deep learning. Suppose it is okay. So is it visible to all? If somebody is
Yes, sir.
it is visible.
No.
Yes, sir. Now it is not there, but earlier it was
Okay.
there.
The
No,
voice
it's
is also, the audio is also there.
Yes, sir. Yes, sir.
Okay, so we developed this model. This is known as object identification models. We trained this model. We developed this model using this TensorFlow unit. So, so what we are doing? So what this model is, we create a model of road here. In this road, we put so many objects, some cars, a cursor, a traffic light, and so many objects we create here. and we put one camera here. And we train this model. We apply some algorithms from the raw data, and we create these algorithms and to train this hardware to identify the objects which are moving on a road. So how this model successfully identify the pictures? Let's play and then we'll discuss about that.
Sir, videos, audio is not available.
ऑडियो इज नॉट अवेलेबल मैडम ऑडियो में आपको एक्सप्लेन देता हूँ कि नाउ वी हैव जैसे हम बोलते हैं मैकेनिकल में कन्वेयर बेल्ट है उस बेल्ट पे हमने बहुत सारे ऑब्जेक्ट्स को रख दिया है और हम ऑब्जेक्ट्स को मूव कर रहे हैं विद डिफरेंट स्पीड से और हम हमारे मॉडल को देख रहे हैं कि हमारा मॉडल कितना एक्यूरेट मॉडल बना है कि वो ऑब्जेक्ट को आइडेंटिफाई कर पा रहा है नहीं कर पा रहा है
राइट
जब रिजल्ट आपको रिजल्ट में शो करेंगे रिजल्ट अगर हम देखेंगे तो आपको रिजल्ट देखिए यहाँ रिजल्ट दिख रहा है कि कितनी एक्यूरेसी से हम आइडेंटिफाई कर रहे हैं तो ये इसकी एक्यूरेसी लेवल इस 47% है कि इसने कार आइडेंटिफाई किया है एज ये आगे 37 और बशर ये इसने ये डिटेक्ट किया 47% इसका ये श्योर है कि ये पर्सन है ये कार आ रही है ट्रैफिक लाइट है तो दिस इज अ मशीन लर्निंग टाइप ऑफ थिंग मींस फर्स्ट वी ट्रेन दिस एंड फ्रॉम दिस ट्रेनिंग डेटा हमने इसको ट्रेन किया पहले डेटा सेट्स प्रोवाइड करके ट्रेनिंग के बाद हमने इसको रियल टाइम में यूज किया तो परसेंटेज ऑफ आपको एक्सपेक्टेड प्रेडिक्शन बता रहा है कि कितना फिट में सही हूँ तो इट्स 47% ऑफ प्रेडिक्शन है एंड इट्स कंटिन्यूअस अगर हम स्पीड बढ़ा रहे हैं तो भी देख रहे हैं कि क्या फर्क पड़ता है इससे
यस सर
तो एट वेरियस स्पीड्स में हमने इसको चेक किया कि कितने लेवल की स्पीड्स पे कितने परसेंटेज ऑफ एक्यूरेसी दिस ये हमको प्रोवाइड करता है so that is main model is developed in this machine learning से हमने मॉडल डेवलप किया था then जो मॉडल डेवलप किया था दिस इज ऑफ यूजिंग टेंसरफ्लो मॉडल यूज किया था इसमें कोरल करके एक सॉफ्टवेयर है दैट इज ऑफ provided by the Google technology platform है by using this Google technology platform we have developed this model so what this platform is this slides is visible na
yes sir
yeah so this Google Coral form will provide you the hardware as well as the software components in case of hardware we have the boards the system and accessories and in case of sensors we have the audio sensor video sensor environmental sensor and motion sensors apart from this at the software end we have the tools compiler machine learning model as already developed model SDKs and operating systems and data sheets SDK reference guides and examples are available so this how this model how this algorithm we have developed and how we create this model by using this Google Coral technology so this Google Coral technology is a hardware software this combination of hardware software and these are the hardware which we have used this dev board that is known as a dev board and this dev board is having the TPU the tensor processing unit that tensor processing unit is specially designed by the Google for this dev board this is development board and USB accelerator is there it's a camera it's a 25 millimeters of 5 megapixel camera you can easily attach this camera with this board environmental sensors so the accessories board that provide the temperature light humidity sensors for the IoT application so all the sensors are present on a single board. You attach this sensor at the sensor board to this Coral board, and you can easily identify these parameters. This is SOAM. So SOAM is a fully integrated system on module in a 40 mm to 48 mm plugged module with the edge CPU on the board. So you can plug this module to get SOAM. That is the accelerator. That is known as a hardware accelerator. To get the acceleration means to get the high processing of the video data or the GPU data. So you can additionally add this PCI card. So to have the high processing of this data. So that is of Google TPUs, Edge TPU. It's a very famous and new terms for in the field of AI and artificial machine learning. This is a center that core of this platform and bringing the machine learning capability on the device. So the Edge TPU is a small application-specific circular chip that the Google designed specifically for the optimizing the machine learning on the device. It is designed to take the TensorFlow Lite machine learning module and it supports the 8-bit quantal TensorFlow models and running on the device with the high efficiency. It runs very fast and the computation at about 4 trillions of operation per second. It's a 4 tops tera operation per seconds. So this is a general Coral Dev boards. So it's a full computer at the SOAP device. So it has 40-pin GPIO header, serial console, the USB 3.0 host, Ethernet 4-pin stereo terminal. The headphone jack is also there. The USB-C port power is there. The USB-C type data is available there. HDMI port is there. And you can mount a camera, you can mount a DSI display or micro SD card. You can connect the micro SD card also. The specification for this Coral Dev boards, technical specifications are: it has a CPU. It's a quad-core Cortex A53 plus Cortex M4F CPU is there. The GPU is a C7000L GPU is there. The TPU is there. Google Edge TPU, machine learning accelerated core processor is also there. The security and crypto, the cryptographic core processor is also available. The RAM memory is 1 GB of RAM, LPDDR RAM is available. The flash memory, 8 GB of flash memory is available. Wi-Fi module, 2x2 MIMO systems with the Bluetooth 4.1. Power is a 5 volt, 3 amperes with the Type-C cable is available. At the USB connection, USB 3.0 is available, OTG ports, USB 3.0, a host port, and USB 2.0 micro B console is also present. So audio connectors is also present. You can connect the audio signal, digital PDM. So it's a complete, it's a simple board with the one, it's a complete computer for to perform a small task or to do the small machine learning kinds of projects. So it is more details. I would just like to show you that the already the models, the inbuilt models are available. The Coral includes a set of machine learning models that are already to be used. Their pre-compiled TensorFlow Lite models are available. They can ready be used on the Coral devices with the Python or HTPU modules, which provide the high-level APIs to execute the TensorFlow Lite model. So the already trained models are available. The models, image classification, object detection, weight imprinting, and the transferring the learning. These models are already available. You can directly use this model. You can directly call this model in your programs, and by using this model, you can generate your application. So suppose here a Python code I have written to get the age detection, the face detection, image detection. So we just initiate the detection engine and we use this model and we import the image and we draw the output. So it's only 4-level model, and with the help of this 4-level programming, Python programming, you can develop your model. So this is a one more project. So we here we train this model with the help of the different objects, and once the model is trained, we provide some other input to that model. It can easily classify that what type of image it has. So it's a very useful TensorFlow Coral code is very useful for designing of machine learning kind of application. And even apart from this app is available. The building a AI, artificial intelligence, machine learning ecosystem together. This app is available. Model.gravitylink.com app is available. The model play, Google Play Store Play, this app is available. It's an object. This is an object identification. It's a flower identification. It's an insect identification. These models are already there. If you face this model with a particular object, it can easily identify. So what potential product areas of deploying the Coral is a Google processor, that is of consumer electronics, warehousing. Everywhere you can use this technology and you can upgrade or you can do whatever you want. The thing is that most of the people are scared about this programming, but the programming is so simple in case of Coral. By using a 4 or 5 line code, you just call a library, you just download your image, you can easily identify the images from that provided image. So it's very simple to write a program, very simple to process. So that is all about this tensor processing flows and the Google Coral systems. So if anyone have any doubts, so we'll go
Sir,
back.
I have a doubt.
Yes, ma'am.
Sir, how will come to know that particular system is working based on IoT or on AI?
Madam, IoT means the processing is done at the cloud end. You have some
Yes,
communication devices. And
Yes,
IoT means you itself process the data at your node itself. Means you sense the data and process the data. That is a different.
That's the thing. Sir, one thing I want to, like in fully automatic machine, we have, they say that it is AI based sometimes.
Yes.
And already the fully automatic machine means it will be, it will be operating based on all the sensing devices.
Okay.
So
Okay, yes, ma'am.
which one I will be calling as a AI device and which I will be calling as a non-AI device?
Madam, AI device means artificial intelligence means itself, it's a intelligent means no one is giving the information कि इसको क्या करना है, वो अपने आप से
अच्छा.
डिसीजन लेगा
Okay.
कि ओवरलोड हो गया तो अपने आप से पता लगा कि अच्छा ओवरलोड हो गया है, इतना वेट होना चाहिए, इतना ही होना चाहिए, तो दैट इज ऑफ
Okay.
एआई. अगर वो कहीं इंटरनेट से कनेक्टेड है और वो प्रोसेस कहीं और हो रहा है डेटा, तो दैट इज ऑफ इंटरनेट ऑफ थिंग्स, और प्रोसेस वहीं हो
Yes.
रहा है, दैट इज ऑफ
Yes.
आर्टिफिशियल इंटेलिजेंस.
Now I okay. Okay. Thank you, sir.
Any participants is having any doubt? Otherwise, we close this session. So no doubt, I think. So we close our third session, and with this talk is of TensorFlow. It's a very useful, powerful CPUs developed by this Google for the MI and AI application. The MI and AI is the next level applications apart from this IoT. So thank you all for joining this. So
sir, can you just take a one question, sir?
yes.
Sir, we just confused that which system basically we can say that this is the machine learning based or AI based?
Sir, the machine learning is a part of AI actually.
Yeah, it is basically you can say the subset of the AI.
Yes.
But pure, if somebody is asking that this is the pure AI application and this is the pure machine learning based application, then which kind of application?
Sir, yeah, in case of the question is, मतलब अगर हम थोड़ा सा देखें तो इस केस में होगा the machine learning means itself updated model is a machine learning model.
Okay.
अगर the model is there, itself updated model, and that is a machine learning. Artificial intelligence means once it is fixed, it performs the same task and it will give the same results.
So can I say that suppose the temperature control in the AC, automatic temperature control.
Yeah.
Is it then AI based application or?
Yeah. You can say that it is AI based, but अगर suppose आपको same AC को आप कहीं और desert में ले जाए जहाँ temperature बहुत ज़्यादा vary होता है, तो it's वो खुद learn नहीं कर पाएगा उसको. अगर self learning model है.
हाँ, इसमें भी तो सर हम बहुत सारा डेटा को सर हम क्या मशीन पे आपका ट्रेन एंड टीएसडी का में देके इसे भी तो हम ले रहे हैं.
पर सर उसमें डेटा सेट्स बहुत लिमिटेड है आपके पास.
अच्छा.
क्योंकि आपके पास लिमिटेड डेटा है, क्योंकि आपको बहुत ज्यादा प्रोसेसिंग नहीं करना है. टेम्परेचर कितना वेरिएशन होगा, अगर हम होम अप्लायंसेस की बात करें 10-15 डिग्री टेम्परेचर वेरिएशन होगा, तो हमने उसको उसी के लिए सेट कर रखा है.
ओके सर, थैंक यू सर, थैंक यू.
So we close this session, and tomorrow morning we'll join again. We have a session from this scientific technology, the Rajiv Kathuria, and then you have a very good session, that is of meditation session tomorrow at afternoon. So we'll close this session and we'll rejoin and meet you again on tomorrow at sharp 9. Sorry, sharp 10 p.m.